Hey everybody, let's spend a little bit of time going over sample problems on how to do ICE charts. Here, if you look, we have calcium nitride and it's decomposing into its elements. Now, in order to write a chemical equation for this, we need to be able to write the formula for calcium nitride. So I'm going to look at calcium, and when I look at the periodic table, I notice it's in the second column, so that means that it will have a 2+ charge. Okay, let me actually get rid of this little hooky-doo here. Okay, so this is going to be a 2+, and I can do the same thing with nitrogen, and I'll find it's in the third column over here. Let's see. So this is 0, 1, 2, 3. Okay, and so it's -3. So when we do this, we determine what the lowest common multiple is, and 6, and so that means we need 3 carbons and 2 nitrogens, and so the formula for calcium nitride is Ca3N2, and this is going to react to form Ca plus N2. Normally, we wouldn't necessarily know exactly what the products of a decomposition reaction is, but in this case, it's telling us that it decomposes into its elements. And so calcium we find as calcium metal, so it's a solid, and then nitrogen we find as nitrogen gas, like in the air. What's the state of calcium nitride? Well, we don't know. It doesn't say. So we have to make some guesses. Calcium nitride is an ionic compound. It's a metal and a metal, or a metal and a nonmetal. So because it's an ionic compound, it has ion-ion forces, and we assume that things with the strongest forces are going to be in the state where the molecules are closest together. And so that's going to be a solid compound. Okay, so now we have included states, but now we need to balance the chemical equation. Okay, well, if we notice, nitrogen is already balanced. But now calcium, there's 1 calcium here, but 3 calciums there. Okay, so now, just like problems that we may have seen before this, it says how much of each product is made in moles. So what I'm going to do is I'm going to take this, and I'm going to do an ICE chart. Okay, and I know that I'm going to start with 149.6 grams, 149.6. Let me make sure that I write that big enough or clear enough. Something's wacky with my pen here. But 149.6 grams. Grams. Okay, now we know that when we do ICE charts, the units of an ICE chart are actually moles. So we have to take this and we have to convert it to moles. So we need a periodic table and we need a calculator. So I have my calculator, I have my periodic table. So we're going to do 149.6 grams of Ca3N2. We're going to X-line this. We're going to do a conversion, and we're going to go from grams to moles. Well, what allows us to interconvert between grams and moles? Well, molar mass. So we need to actually calculate the molar mass before we go too much further here. And calcium, I'm going to look on the periodic table, and calcium is 40.08, and then nitrogen is 14.007. Now, when I do this, I'm going to just kind of abbreviate 3 times 40, and nitrogen is 2 times 14, because I'm a teacher and I've earned the right to abbreviate. Based on whatever periodic table you're using, you're going to put the decimals out there. Okay, and so let's see. So we're going to do this, so it's 3 times 40, which is 120, plus 2 times 14, which is 28. 120 is 148. Right? So this is 148, and the units on that is grams per mole. So I'm going to put this, for every 1 mole, there's 148 grams. So I do 149.6 divided by 148, and we get 1.01. And now we have to look at significant figures. In the calculator, we should use 4 significant figures for our answer, because we have 4 sig figs here. So we're going to have 4 sig figs all the way around. So this is going to be moles of calcium nitride. So this is 1.011. And because the ICE chart is all in moles, we don't have to actually write the unit here. Okay, so now let's add some stuff, or let's make sure we put some more stuff in the ICE chart. This guy is going to be used up, so we're going to have 0 of that at the end. These two things are being produced in the reaction, so we don't have any of those to begin with either. So this, we're going to subtract 1.011 moles. That's the only way we're going to get this down to 0. So we're going to add some things on this side. It's okay to put your plus here. Okay, it's not positive, it's plus. It's an actual mathematical function. And so now, because we have this change box here, we can calculate every other change box in the ICE chart. So let's do that. Okay, we want to go from moles of this to moles of that. In order to do that, because we're moving across the ICE chart, we use the coefficients, the ratio, the balanced chemical equation, whatever you want to say there. So I'm going to separate this a little bit. Okay, and I'm going to take 1.011 moles of Ca3N2. I'm going to X-line this guy, and I'm going to, instead of doing anything with moles, I want to get rid of Ca3N2 and convert that to calcium. Okay, so for every 1 mole of this, we have 3 moles of that. Now I get it, when we look at this, you may be able to do that math in your head. You're more than welcome to do that math in your head. If you need a calculator, go on. Please do so. Okay, so 1.011 times 3 is, of course, 3.033. And the units of that, look, CAN cancel, and so we have moles of Ca. So this is moles of Ca. So we're going to go up, and we're going to put 3.033 in there. Okay, now we're going to do the same thing with nitrogen. We're going to use the first change box that we calculated. We're going to X-line it. We're going to put Ca3N2, but now we want to convert that to N2. And this is for every 1 N2. We use the, we get 1 Ca3N2. And so this, we use the coefficients. Now, this you probably don't need a calculator for, because we're just multiplying by 1 and then dividing by 1. And so this is going to be 1.011 moles of N2, because CaN3 and calcium nitride cancels, leaving just moles of N2. So again, we're going to put this up here. So this is going to be 1.011. And so now, at the end, we have 3.033 and then 1.011, and that is our answer to part B. So we've done the reaction, done the equation, I guess. We've figured out how many moles. Now we need to determine how many grams. And how do we convert moles to grams? Well, we have to use the molar mass. So now we do kind of the same thing that we've been doing. 3.033 moles of Ca, and we need the molar mass of calcium. We have our periodic table. We looked up that the molar mass of calcium was 40.08. So we're going to convert from moles to grams, and we're going to go for every 1 mole calcium weighs 40.08 grams. So 3.033 times 40.08. Okay, and that's going to equal 121.6. Now, this is a final answer, so I'm going to use 4 significant figures because that's how many are in our sample problem. So that's grams of calcium. So I will write that here as well. I'll put it in green just so it's not confused, but that's 121.6 grams right there of calcium. We do a similar calculation to find out how many grams of nitrogen we have. Okay, so we'll do that. So we have 1.011 moles of N2. And again, we're going to X-line it. We want to get rid of moles, and we want to convert to grams. Okay, moles cancel. We're left with grams. And I know every 1 mole weighs 28 grams. Okay, for nitrogen gas. And so now I'm going to go 20. Let's make sure that I do it in the right order. 1.011. We know that multiplication you can do in any order, but I want to make sure that my calculation reflects what I'm doing here. So it's 1.011 times 28. And so that's going to give us 28.31 grams. And again, I'm using 4 significant figures because that's how many there was in the problem. Okay, that we were given. We were given 4 sig figs here. Okay, so now we go here, and we go 28.31 grams. Perfect. Now we just have to double check this. Okay, the double check is the law of conservation of matter. Okay, I'm going to split this up here. Okay, and I'm going to look. I'm going to say, well, how many grams did we start with? Because that should be equal to how many grams we ended with. Matter cannot be created, nor can it be destroyed. So here we're going to start. We started with 149.6 grams. Okay, there's none and none there. And then we ended with, well, none plus 121.6 plus 28.31, and we ended with, let's see, 149.91. Okay, now that's very, very close. I would say that that's right on, because we're rounding our numbers and rounding our answers, and people are using different periodic tables, so it's fine. We're off in the last significant figure there by 0.3. I'm fine with that. Okay, so there's that problem. Yeah, good stuff.